Hello, my name is Dennis Michael. I work for the Environmental Protection Agency, Office of Air Quality Planning and Standards. This video will illustrate a calibration of two types of meteorological equipment, the temperature and relative humidity sensors. It is normal practice to calibrate both of these sensors because they are combined sometimes into one sensor. First, let's talk about why we need these sensors at monitoring stations. Temperature and relative humidity inform us about the thermal properties of the environment. Temperature is useful in determining the reactivity of the atmosphere. In addition, it is used to determine the amount of rise experienced by a buoyant plume. Relative humidity is related to the amount of moisture in the air. It is an important variable in determining the impacts of moist sources, such as cooling towers. It is also used in modeling ozone photochemistry. Before we get going, let's define what we mean by a calibration. EPA defines a calibration as a comparison to a measurement standard, instrument or item with a standard or instrument of higher accuracy to detect and quantify inaccuracies and to report or eliminate those inaccuracies by adjustments. So you can see there are two parts to this process. Primarily, the measuring of conformance, and secondly, adjusting to that conformance. What this translates to is testing and adjusting the instrument to see if it meets our standards. For temperature and humidity sensors, this means imitating the temperature or recording of the humidity and temperature with a separate sensor. In this instance, the temperature sensor will be calibrated using 3 water baths. The probe will be immersed in the baths and a traceable sensor will measure the temperature of that bath. The RH or relative humidity sensor will be immersed in the salt solutions that have a known relative humidity. The values will be read and referenced to the RH of that solution. Calibrations of meteorological systems always take at least 2 people to perform. The reason is simple. While one person is performing the test of the instrument, another person must record the responses. This is a typical meteorological tower. There are several types of towers commercially available. The different types might be collapsible, tilt-down or crank-down towers. This tower is a crank-down tower. This temperature sensor is a Met1 Corporation Model 062. It is attached to the tower at approximately 2 meters in height. This makes it easy to access. Towers are not always needed for temperature and relative humidity sensors. Sometimes they can be mounted on the top of a shelter railing. Temperature probes or sensors must not be exposed to sunlight. A temperature probe can act as a thermal mass and absorb sunlight and give false readings. Temperature probes must always be housed in a protective covering. In this instance, the temperature is in a motorized housing. The probe is housed in one end and the motor draws air through the housing from the other end. Air is pulled through the inlet of the housing to ensure that the air is not stagnant. The device we shall use to calibrate the sensors is a submersible thermometer. All temperature calibration devices must be NIST traceable. NIST stands for the National Institute of Standards and Technology. Purchase only those calibration devices that are NIST traceable. At this time, the outside technician is removing the probe from the housing. Care must be taken that the tip of the probe is not damaged. Proceed with caution. Insects may have built nests inside the housing. Once the probe has been removed, it should be inspected for dirt, debris, or damage. If none are found, it is time to perform the calibration. The first task is to record the location, operator, date, and GPS coordinates. The second task is to record the instrument make, model, serial number, and full-scale range. You will note that the calibration form has a set of tables. The first column in the top table should read calibration points degrees centigrade, and the second column should read DAS response in degrees centigrade. The calibration thermometer results will be recorded in the first column, and the DAS response in the second column. If there is a chart recorder, these will be recorded in the fourth column. Once the probe has been exposed, the outside technician will prepare the first water bath. This is performed by adding ice to water in a container and creating an ice slurry. The best results come when the ice is crushed or broken into small pieces. The probe and the calibration thermometer are now placed in the ice slurry together. A helpful hint here is to tape or rubber band the calibration thermometer and the temperature probe together so they measure the water in the same area of the slurry. it is recommended that the outside technician stir the probe and thermometer. Now that the first calibration point has been recorded, the outside technician must now prepare for the second calibration point. This is performed by adding ambient temperature water to the water container. The outside technician has dumped out the water slurry and will now prepare for the second calibration point. With the ambient temperature water in this container, the probe and thermometer are placed in the water bath. The outside technician should stir the water to avoid pockets of different temperatures. After the thermometer stabilizes, the outside technician then records the value from the thermometer. The inside technician records the DAS reading as well. With the second calibration point finished, it is time to prepare for the third and final calibration point. The outside technician heats water to approximately 40 degrees centigrade. He then dumps out the ambient temperature water and pours the hot water into the container. With the hot temperature water in the container, the probe and thermometer are placed in the water bath. The outside technician should stir the water to avoid pockets of different temperatures. After the thermometer stabilizes, the outside technician records the value from the thermometer. The inside technician records the DAS reading as well. If the responses to the calibration are within the specifications for your program, then the sensor or DAS do not need to be adjusted. If the adjustments are made, it is recommended that you rerun the calibration points with all 3 water baths to reaffirm that this is true. This concludes the temperature calibration. Dry off the probe and reinsert it into the housing. Our next task is to calibrate the relative humidity system. The sensor that we will calibrate today is a Met1 Corporation model 083D. Before we start the relative humidity calibration, let's record all of the pertinent information on our calibration form. The relative humidity probe is removed from the housing. Care should be taken so that the probe is not damaged. The same issue exists with this probe as with the temperature probe. Insects can nest in these housings. Caution should be taken. Once the probe is removed, insert the probe into the calibration solution. Allow enough time for the sensor to stabilize. Usually several minutes are needed. Have the inside technician record the value from the DAS. Record this value on the calibration form. Once the system is stable, remove the probe and clean the solution from the probe. Once the probe is removed and cleaned, insert the probe into the second calibration solution. Allow enough time for the sensor to stabilize. Usually several minutes are needed. Have the inside technician record the value from the DAS. Record this value on the calibration form. Once the system is stable, remove the probe and clean the solution from the probe. If the responses to the calibration solutions are within tolerance, replace the probe in the housing. If not, adjust the response of the sensor or DAS and perform the calibration a second time to reaffirm that the adjustment is within tolerance. This concludes the calibration of the temperature and relative humidity meteorological measurement systems. I invite you to read up on meteorological monitoring, and a good place to start is EPA's QA Handbook Volume 4, Meteorological Measurements, which is on EPA's AMTIC website. The website is listed at the bottom of your screen. The EPA has also created video calibration procedures for other wind speed and direction systems, temperature and dew point systems, and tipping bucket systems. You will find these videos on the AMTIC website. From all of us at EPA's Office of Air Quality Planning and Standards, thank you for viewing this video.